as we are learning about Arduinos, when we are at home, we have a tool called TinkerCAD that is an awesome simulator for not only building and hooking up circuits and creating diagrams, but also for programming and testing the function before even using any of the regular components. So since during blended and remote learning, you might be doing some of the Arduino activities at home, TinkerCAD is a great tool to use in place of the actual kit and the coding software. So the first thing we want to do is most people think, oh, I've never been here before, so I should join. And they try to click join now. Don't do that, okay? Because our school district already provides us with a Google account, the easiest way to do it is just go straight to sign in. And once you do that, you're going to click sign in with Google. Now, because I've done this before, mine is going to ask me just to select an account, and then it's probably going to go right in. Yours will probably have you select an account, or you may have to actually type out your email address, which is fine. And then it will probably prompt you for your password. Okay. If you're using the same computer, and especially if you have saved passwords turned on, you should just then be able to continue working. Now, TinkerCAD is actually kind of a light duty, kind of an interesting entry-level, elementary type level 3D design program as well. That's not what we're going to use. So when it says 3D designs, if you have stuff here, that's really not what we're looking for. What we want to go to the one is the one that says circuits. This is where we want to go. Okay. As you can see, I've done some circuits already. You're going to be starting from scratch, so you don't have a lot of this stuff done yet, which is fine. Okay. So when you go, you're going to click create new circuit. And after it loads, whether you are doing the very first circuit, which is the one I'm going to use as an example here, or whether you're doing the last big final project with a very huge complicated one, still the first thing you're going to do is come to where it says components, basic, drop it down and go to starters and Arduino. Okay. The one that you want is the breadboard here. So I'm just going to click that one, and I'm going to click to set it out here. Okay. Don't look at any of the rest of these. Some of these are very similar to some of the activities we're going to do, but as you can see, you won't have the breadboard. And so when you take a snapshot of it, I'm going to know that this wasn't the way that we had it hooked up. I want to see the breadboard because this is good practice for being able to also do these same types of circuits in person. Okay. As a quick reminder, we have a positive bus, which is right here. So you can see if I hover over the dot, it shows those green circle in lines to show you that all of those little ports are connected. So anything that's plugged into any one of these ports is also connected to this red line that goes around to the 5-volt connection on our Arduino board. The same is true for the black one, okay, which is in the negative bus here and is connected to one of our many ground ports. These wires over here just connect the upper buses to the lower buses, so it does not actually matter. So if I connect something to a positive bus up here and you want to connect it down here, it's fine. It is the same. Okay, so this is our starter. From here, and this is the way we're going to start every circuit we build. From here, we're then going to go back to the components, and you can either do basic or all. Now, when you do basic, some of the real common ones are up top right here. The other thing we have is a search bar. Okay, so if there's anything you're looking for that you don't see here, or you don't feel like trying to scroll through and maybe possibly find it, just start typing it in the search bar, and they'll help it. One of the things that we'll work with in a little bit is a photo resistor. So if you even just start to type photo, you'll find it here. And you can see it's the first thing in my list. I can click the X and it goes back to the start. Now, the first circuit that you're going to do is just a very simple LED. Okay? So the first thing I'm going to do is I'm going to bring my LED out, and I'm clicking and dragging, and I'm going to pick 2 rows to drop it in. Okay? Anytime you drop a component, the options you have for that component are up here. Okay, we can name our LEDs, which when we get into more of our final project and we have quite a bit going on, You might want to start naming them in terms of their function. We'll just leave this one as name 1 right now is just fine. Okay. The other option you're going to have is the color. Okay. So again, when we get into our final projects, maybe you want to use a red that signifies one thing and a green one that signifies a different thing. All right, you can just drop it in and then change it. You aren't going to find different colored LEDs in here. We bring the LED in, we change the color. Okay. The other thing the other component that we're going to need is a resistor. So as I bring this resistor out, I'm going to make sure that the resistor goes to, I believe it is the negative side or the anode side of the, I'm sorry, the positive side or the anode side of the resistor. I'm going to double check our agreement here. Now remember, it does not matter the fact that this is sideways compared to what we're used to, and that the analog and power ports on this board are closest to the circuit or to the board, and on here they're farther away. Okay, that actually doesn't matter. Just make the connections like we'll use pin 13 and we'll use ground. Okay, use those same pins even though they're not necessarily on the same page on this example Arduino board. But what you will look at is the anode, which is the positive side, which is the longer leg, connects to the resistor, which that's exactly what I did over here. Now, when you bring the resistor out, it automatically drops in a 1 kilo ohm resistor. On our SparkFun page, we are told that we're using a 330 ohm resistor. So make sure that you change, I would change the number first, 330, and then the unit second, because it's not kilo ohms, it's just ohms. So a 330 ohm resistor, or as you can see, the stripes go orange, orange, brown. Now, the last thing we have to do to this circuit to make it work is we have to start to wire it. Now, the way that they have it wired, any one of these pins. So first off, I did want to point out that having the resistor across the groove makes it so that this end of it is not connected, to this side, because you'll notice these 5 column dots are connected and these 5 column dots are connected, including connecting the resistor to the LED, which is exactly what we want. Our next order of business is to go in this group and click and wire this to pin 13. They say D13 because it's digital 13. Okay. Now our other one, the negative size of our LED, can go one of 2 places, and I'm going to count both of them as correct. I can click here and wire it to the ground. That is technically true. That will work. The other thing I could do is I could take this to the negative bus up there. I could also take this to the negative bus down here. Now, one of the things you'll notice is this is not a great option because the wires cross. Okay, I'm actually going to delete both wires because that, as you saw, was fairly messy. Okay, so the first thing I'm going to do is I'm just going to wire this straight down to the negative bus. You'll notice again the wire color comes out. Now, what color wire does it actually really matter? No, it doesn't in real life. I think you're going to find that it's much easier if you do try to keep the concept of this is connected directly to ground. So I'm going to change the wire to be black so it matches the rest of the stuff. You're going to notice that that's really, really helpful. There's going to be other times where it makes a lot of sense to change it. Okay, so since this is directly connected to ground, I'm going to make it black. Now this one, if I pull it across, it's going to cross, and it's honestly not going to look that good. Here's a little trick. When I start my wire, if I come down not on a dot and I click, it puts a bend in the wire. I'm going to come over to just above where it says 13, click again, and pull down to 13. Now this is a signal wire. It is not a positive connection. It's not connected directly to positive. So what I'm going to do is turn it, in the other one it was yellow, blue works good, okay? Any color that shows this is a signal wire. So again, not red, not black. Okay. If any of these twists or turns aren't quite lined up, you can click on it and you can move these dots around. So as you can see, mine is lining up both horizontally and vertically. I'm going to double check the other corner and make sure that we are horizontal and vertical. And again, it's got those nice turns in it, so my document looks very, very clean. Okay. This is correctly wired. Now, You're probably going to go, okay, great. I got it set up. Now the tutorial tells me to copy and paste the code into the software. I don't know how to do that. Here we go. First thing I am going to do is I am going to go over to the circuit, and I am going to click the button that says copy the code. Now, normally we just copy it and then we paste it into the Arduino IDE. When that's not available, when we're doing this on our online simulator, we've got a code window right here. So when I click on that, it's going to bring this out, and you're going to see this as kind of a Scratch-based coding program. You can use this with Arduinos, but that is not what we're going to do. We want text-based coding. Okay, you can see that there is some stuff already there. I'm going to highlight it. I'm going to push delete and Control V on my keyboard, paste it. Okay, so as you can see, I have now pasted the code. One of the things that you will notice, number one, by the way, I'm using the scroll wheel on the mouse. We'll zoom in and out. And if I click and hold it, it moves things. I'm going to undo that. Oh, wow. Okay. Sorry. I didn't realize that would undo my paste. Okay, I'm going to go ahead and grab. Sorry. Now I'm really messing it up. One more time. Wire, go away. All right, I'm going to close the code window and see if that's my problem. Wire goes away. This gets moved back so that everything is good and right with the world again. Click my code window. Here we are. Okay. So now that everything's back to where it should be, I'm going to go ahead and click. Now, again, I'm not seeing anything going on. You know, if I read the thing, it sounds like the LED should be blinking or something like that. You have to click Start Simulation. Okay. And it seems that I have an error. One of the best things to do is I'm going to delete that again. I'm going to come back here and I'm going to copy the code again. And I'm going to try pasting again. I'm assuming that I did something. Yeah, because I ended up deleting some of this stuff, and that's where my problem was. So I'm going to start simulation again. It initializes it. It turns green. You'll notice that this plugs in. And if I look at my LED, it is now blinking. Okay? This means my circuit is functioning and is working the way it should. Okay? One of the other things that you'll notice about all of your assignments is they then have you make changes in the code. Okay? So as you make a change in the code, the best way to do that is to stop the simulation, make your change, and then start the simulation again. That way you know for sure that whatever it is actually what is now showing. And you will notice that there is a difference. Okay? Now, for the assignments, one of the things it asks for is a copy or a picture of your circuit. You can use either your snipping tool on a Windows computer or any screenshot tool and then crop it down so all you see is the actual circuit itself. Whether it is on or off, unless it's specified in the question that you're asked, it really doesn't matter. Okay? The other thing that's asked for is a copy of the code or Arduino IDE. So again, we're going to look at this area, okay? And you're going to want to screenshot this area right here, okay? Make sure you answer the questions as you need to for whatever's going on. And that is how you build the circuits. Oh, before we end, last thing. You'll notice that just like Google, it puts the name up here. Okay, it's got some weird naming protocol. I don't even really understand it. But if you click on it, you can change the name. So if I were you, I would call each one of them activity, and then whatever activity it is. In this case, it is 1A. Now, if I save this as activity 1A, I'm going to overwrite my existing one. So I'm going to call mine 1A again. That's just so I don't change my other one. But again, you're going to want to call these activity 1A, activity 1B, 1C, 1D, 2A, whatever it is that we're doing. You're going to want to use that as kind of some sort of naming protocol and not leave the names the weird stuff that they call it. Because if at any point I click on TinkerCAD, I go back to my dashboard, I go to my circuits, and you can see the most recent ones are first, but it does make a lot of sense that you can see like what's going on in each one. That's how you use TinkerCAD to complete any of your Arduino training activities, including our projects.